right, welcome back in your quest for knowledge. This video answers the question, what if I have a system of three equations and three unknowns, and it's not set up easily for back substitution? How do I attack it? This can be pretty complicated. I'm going to outline a method that pretty much always works. It's a little bit of work. There's a little bit of work involved, so some people don't like it, but your reward for using it is that you'll be led to the solution if you can follow through the steps. That's the question we're trying to answer. How do we deal with a system that's not set up for back substitution right from the get-go? And so the answer is we make use of something called elementary row operations. These are three things you can always do to any system. You can swap any two equations, rows of the system. You can multiply an equation, row, by a constant, or you can add a multiple of an equation or row to another equation. And in each case, you replace one of the equations with the result of your elementary row operation, and you always get an equivalent system. I'm not going to go into why those work, but we just want to roll up our sleeves and get going with these. So I can talk about them, I'm going to label these rows, row 1, row 2, and row 3. We're going to just start off with some elementary row operations. I like that first row. The result that we're striving for is called row echelon form, and I'll say more about that a little bit later. So I'm going to just recopy row 1. I'm going to keep x minus 2y plus 3z equals 9. With row echelon form, you strive for the coefficient of each variable to be 1. And so the first row is going to have x in the first position. Now we want to try to get an equation that has no x at all and a y in the first position. Is replace row 2 with the sum of row 1 and row 2. So you see up here, if I just add these two rows together, row 1 and row 2, the x term is going to drop out, and also the y term is going to be set up the way I want. So the way I'm going to show that is that row 2 is going to become row 1 plus row 2. So row 2 is going to become no x, 1y, and 4z equals 7. So y plus 4z equals 7 is my new row 2. And now what I want to do with row 3 is multiply row 1 by negative 2 and add it to row 3. And you can see what's going to happen if I do that. My row 3 is going to become negative 2r1 plus r3. And if I do that, you can see what I'm going to get. The x's are going to drop out, and I'm going to get another equation with a y and a z in it. So hopefully that I'll be able to eliminate the y, because my row 3, I want to know what z is alone. So when I do negative 2 row 1 and add it to row 3, negative 2x, and add it to 2x, and so x is going to disappear. Then it's going to be positive 4y added to negative 5y, and that's going to give me negative y. Negative 6z plus 5z is negative 1z. And finally, negative 18 plus 17, and that's going to give me negative 1. So this is a new system. I really recommend that each time you go through a system and make some changes with elementary row operations that you recopy the system. It's going to involve some work for you, but I think you'll see the advantage of it, and you'll be able to more easily keep track of your work, and I'll be able to more easily keep track of your work. So here we go. I want to eliminate the y's so that I only have a z in the last term. So my row 3 is now going to become the result of adding row 2 and row 3. Because when I do that, these y's are going to cancel out. And so I'm going to have x minus 2y plus 3z equals 9 in row 1, and y plus 4z equals 7 in row 2. I'm just going to have 3z equal to 6 in row 3. This is my new row 3. Now, examine this carefully. The system that I have here is in what we call row echelon form. Even though I haven't gotten a coefficient of 1 in the z, I mean, technically, yeah, okay, z equals 2. That's row echelon form. But as soon as I get it to this point, I'm set up for back substituting. I can plug the z into here and find out what y is. And then I can plug z and y in here and find out what x is. So we're going to just go ahead and do that really quickly. When I plug z equals 2 in here, I get y plus 8 equals 7. So y equals -1. And when I plug -1 and 2 into here, I get x plus 2 plus 6 equals 9. X plus 8 equals 9, x equals 1. And so my solution is 1, -1, 2. Now see if you got the same thing or if I made a mistake. But anyway, what we're striving for is row echelon form. It's something that takes a little bit of practice. And like I said, there's work involved in recopying the system each time before you tackle the next row. But hopefully you'll see that it's worth it. All right.